Okay, welcome back to how to build a SaaS service on Azure. This is part 3, microservice architecture. In part 2, we discussed the database tenancy patterns that are available. And now that we understand those, we can move on to the architecture for the overall solution, the overall SaaS solution. And of course, with that, we're going to be recommending a microservice architecture. So for those who are not yet familiar with what are microservices, I will give a brief overview. So microservices are essentially small, independent, and loosely coupled services. By loosely coupled, we mean that we individually create services that pertain to a particular topic area of your solution. For example, a service just for orders, a service just for customers. Okay? Each microservice has its own separate code base, which can be managed by a small independent development team. And that development team can then fix bugs, make updates to that particular service, deploy it out with minimal downtime for the solution as a whole, and without impacting potentially various components of the solution at all. Okay, so as we said, a team can update an existing service without rebuilding and redeploying the entire application, which is a major advantage. So services again are responsible for persisting their own data or external state. So what that means is if you have an API for your customers, you will also have a respective database for that customer API. Okay, and that database, that back end for that service, then becomes a part of the customer microservice. Okay, services communicate with each other by using well-defined APIs, and by doing so, there's also security that's implemented in the Azure SaaS Development Kit that we're going to be reviewing. We'll see that that security is done, for example, using OpenAPI, using OAuth 2.0, and app registrations within Azure AD. And then services do not need to share the same technology stack, libraries, or frameworks, right? So you could have one API that's built completely using C Sharp on .NET, and another that's built using Java, also deployed out to Azure. Okay. So a typical microservice architecture could look as simple as this. Essentially, what you see on the left side is your client. So your client could be your web browser, a mobile application, okay? And that application, whether it be via the browser or your mobile device, speaks to an API gateway, and that API gateway provides a large amount of functionality, essentially the ability to limit the amount of traffic, the ability to secure what traffic passes through it, and the ability to control what traffic passes through it. So you'll see here that we have 3 or 4 different services. So those could be, for example, your customer service, your order service, a logging service, and a notification service. Okay, and then on the right side, we have the developer operations, better known as DevOps, and continuous integration and continuous delivery processes that would take place there. So next, we're going to look at the crux of this session, which is a multi-tenant SaaS microservice architecture. It's a lot to take in, but essentially what we're looking at here is a number of microservices that pertain to any standard SaaS solution. Starting from the top down, we have an onboarding flow service, and then we have an onboarding service. Now, those are 2 different services, and I'll explain what those are. So the onboarding flow is essentially when a prospective customer comes onto your SaaS platform and they begin to onboard. They enter their information in, they enter their email address, they enter, for example, additional views that you might have that have form fields that also need to be submitted prior to full onboarding. So let's say, for example, they need to enter their email address, a category, what they want their organization to be called, what their billing tier they're going to select. So all of those have to be selected before they actually get to the onboarding service itself. And that actually has a Cosmos DB backend so that you can quickly and very performantly capture that information, even if they do not progress through to full onboarding. So now you have data in Cosmos DB that you can refer back, communicate back to them to understand better why it was that they did not complete the onboarding process. The onboarding service itself then takes all of that data that was captured and then submits it actually into the onboarding backend. And at this point, they would have gone through billing if billing were required, right? So there might have been a freemium option that does not require billing. The identity service is essentially where once a organization comes in and provisions a new tenant, then the individual who was creating the tenant would most likely be added as a owner per se of the organization or an administrator of that organization, and they would then be stored in our identity backend, right? So our identity service could be one of many. It could essentially be ASP.NET Identity. It could be Azure AD itself. It could be using Azure AD B2B or Azure AD B2C. And then what we see behind the API is a SQL backend. And then we see a logic app. And what that logic app is essentially doing is providing another administrative low code, no code means for you to receive notifications whenever a new user comes into the system. Those notifications could be for the SaaS provider, which is you, or it could be for the owner or administrator of that tenant. Moving down, we see the billing service. The billing service would essentially be an API that speaks to whichever merchant provider you're using. In this case, in this example here, we're demonstrating Stripe, but that could be, again, any backend service, PayPal or any other, for example. The order service is essentially for the purposes of capturing a log of all your orders that have come in. Again, the billing and the transaction will be done via your merchant platform. Again, in this case, it was Stripe, but you do want to have a data store that captures all of your order information and all of the metadata that revolves around that. Same goes for the customer service. You would have captured a lot of the information in the onboarding portion, but this is where the microservices also speak to each other. And from the onboarding service, it would have created a new tenant in the catalog database, but in addition, written a new order record as well via the order service and customer service. And then further down below, we have the logging service, which is also a Cosmos DB backend. And what that allows you to do is capture logs of any transaction that exists or any activity that exists throughout the application. So you could have, for example, a logging service for all actions, as well as a exception log that's separate. It's in a different Cosmos DB for any framework exceptions, .NET Core exceptions, .NET exceptions that may exist. Okay. Below that, we have a notification service, again, which uses a function app. And this talks to SendGrid for email capabilities. And what this does is this essentially processes, for example, timed emails that may be going out on a scheduled basis, whether they be with reports or whether they be for notifications of new activity, of new users, or what have you. So these would work through a time-based trigger function app and function itself using cron expressions, for example, and would send a SendGrid-based email. And then finally is our catalog database service, which manages everything revolving around a tenant record and the activity around that tenant itself. On the left side are our clients, a multi-tenant SaaS provider web application. So that's going to be your Salesforce.com, for example. That's going to be the main web application that users will navigate to leverage your SaaS service. The admin web application is a web application in which you, being the SaaS platform owner, or administrator, or system administrators of the SaaS of the SaaS solution would have access to. And then down below are the cross-platform mobile apps for the overall SaaS offering. So here we have a microservice architecture for a multi-tenant SaaS solution, loosely coupled, where we have each solution, each service in its own resource group, okay? And also on the bottom right, you'll see an Azure repo. Again, because you're going to have individual teams managing, developing, upgrading each independent microservice, it's important that the actual code base for that is isolated in its own Azure repo so that just that team will have access to the CI/CD pipelines and the repository of code that exists there. Okay. In the next section, we will look at how to get started now that we have reviewed the database tenancy patterns, a microservice architecture for a multi-tenant SaaS solution, and how do we now take those learnings and just get started and get a SaaS service up and running on Azure.